A traditional lift question for question 3. We have a lift of mass 2,500 kilograms which is ascending with acceleration of 1.8 meters per second squared. What I have to do first is calculate the tension in the lift cable. Okay, whenever you have a question like this with a lot of words, first thing you've got to do is draw a diagram, just so you can visualize what it is. So, make it easy, drawing this already. So in this diagram, we didn't put in what we've got. So the lift of mass 2,500 kilograms, and it's ascending, so it's going up, or the acceleration is 1.8 meters per second squared. This cable here, the tension in the cable is pulling it up, and its weight is pulling it down. So the weight is mg. As it's ascending, so for part A, as the lift is ascending, the force, so the force pulling it up, the ascending, the acceleration upwards, is equal to the tension is pulling it upwards, but pulling it back is its weight. In the question then, we put in the values we've got. So the mass is 2,500, the acceleration is 1.8, t we don't know, minus 2,500 times 9.8. 4,500 equals t minus 24,500. So rearranging, we end up with t equals 29,000 newtons. Okay, we could have at this point, we could have an alternate method. We could have rearranged that to give us t equals ma plus mg, t equals m a plus g. Put those values in, we'd have 2,500 times 9.8 add 1.8, and we get the same answer. Okay, so part B. Now we're looking inside the lift. So for part B, we're looking inside the lift. And we're saying a person of mass m kilograms stands on the floor of the lift. Given that the magnitude of the reaction at the floor and the lift, so R, the normal reaction, is 696 newtons, find the value of m. So as before, diagram, just so I can see what's happening. I've got a person in there as well. So this time, we don't really care about the tension outside. I shouldn't really even really have drawn those bits. All we care about now is what's happening inside the lift. So it's still accelerating at 1.8 meters per second squared. Okay, the normal reaction R equals 696 newtons, and pulling it down against the floor of the lift now is its weight of the person, not the lift. That's mg. I call the capital M, that's what it's got in the question. So now, for this person, the force acting on that person is the normal reaction, because again it's going upwards. Take away, subtract its mass. So to keep things tidy, let's rearrange it. So put this over that side, we have ma plus mg equals r. Factorize it in terms of m. So that m equals r over a plus g. Substitute the values in. So the values we've got are r is 696, a, the acceleration, is 1.8, and gravity acceleration due to gravity is 9.8. So we put these values in to our equation. We end up with a mass m is 60 kilograms.